All right, chapter 4, section 1. Your test is 3-1 to 4-1. This is the mechanics of finding all of the things that you need to graph rationals. You will not be graphing rational graphs on your test on Tuesday. When we return from Christmas, that first week back, we're going to practice graphing this stuff, and then you'll have a quiz on just that. But that'll be after Christmas. So the only thing on your test that has to do with rationals is the mechanics behind it. And once we go through this, you guys will be like, oh, okay, this is not bad. All right, let's talk about what a rational is. Rational is a grown-up word for what? Fraction. Okay, good. We remember. So this is what a rational graph looks like. Okay, I did this in highlighter so you could see. Again, we are not graphing these. You will after Christmas, but I just want you guys to see what it looks like. This is the parent function right here. This is our parent function of a rational. Our parent function for a parabola is x squared, right? Parent function for a cubic is x cubed. The parent function for a rational graph is 1 over x. So in this case, guys, what is the only thing that x cannot equal? Why not? Because it makes your fraction undefined. So when you have rational graphs, you're going to have these imaginary boundary lines that your graph will get really, really close to and not touch, and they're called asymptotes. You have a vertical one. What's the direction of a vertical anything? Up and down, right? You'll have a horizontal one, left and right, and then you could possibly have a slant asymptote. Show me a slanted line with your hand. There you go, okay? So this is what the parent function looks like. Your graph gets really, really close to the x and y axis, but it doesn't touch it. One thing, and we'll talk about this a little more, I sometimes call this the boomerang graph because it kind of looks like two little boomerangs. Your graph can cross slant and horizontal, but it will never, ever, ever, ever cross a vertical asymptote. Because where you have a vertical asymptote is where your fraction is undefined. So it'll never cross. But again, you don't really have to know that right now until after Christmas. So this is the mechanics behind everything. These next two slides are super duper important. All right, asymptotes, those are our boundary lines. They're imaginary. They're not solid lines, they're dotted lines. But there's 3 of them that we're going to talk about. And after I go through this, you guys are going to be like, oh, this is easy. We're going to go through it. We're going to practice it. We're going to be good to go. If you are finding the vertical asymptote, mechanically, how do we do that? What does it say to do? Set the denominator equal to 0. We've done this before. This is how you find the domain. Remember, we talked about domain restrictions and stuff like that? So to find your vertical asymptote, you set the denominator equal to 0. It's that simple. And again, your graph will never, ever, ever cross your vertical asymptotes. Never. Horizontal asymptote. Notice here it says it can cross it. It doesn't always, but it can. It mechanically might. But the way that we find the horizontal asymptote, if there is one, is you compare the numerator degree to the denominator degree. All right? What's the degree of a polynomial? The highest what? Exponent. So you're just looking. You're looking for the highest exponent in the numerator, highest exponent in the denominator, and you're going to compare them. If the numerator degree is less than the denominator degree, where is your asymptote? What does that say? Y equals 0. Guys, if you do not have y equals and x equals, it's wrong. We're writing equations of lines. It's very important that you have y and x. If, guys, the numerator degree is bigger than the denominator degree, what's your answer? There's none. We don't leave it blank. We write none. And then the last one is the easiest one. If the degrees are the same. If the degrees are the same, you compare the leading coefficient of the numerator. It's y equals the leading coefficient of the numerator over the denominator. I'm going to go over it in a second. Hi. And then the last one we're going to talk about is a slant asymptote. But let's talk about horizontals here for a second. I'll show you a couple examples and show you how simple this is to do. So we have f of x equals, say, 2x over 3x squared plus 1. And then I'm going to say f of x, equals 3x squared minus 4 over negative negative 5x squared plus 1. And then we'll have f of x equals 3x cubed minus 6 over x squared minus 4. All right, 3 different examples here. Just made them up. If I was going to find the vertical asymptote, how do I find the vertical asymptotes? Set denominator equal to 0, okay? If I'm going to find the horizontal asymptote, this is how we're going to do it. We're going to compare the numerator degree to the denominator degree. In my little example 1 here, what is the degree of the numerator? 1. What is the degree of the denominator? 2. 1 is what then 2? Less than, right? It's either less than, greater than, or equal to. So if my numerator degree is less than the denominator degree, what's my horizontal asymptote? Y equals 0. You would write your horizontal asymptote is y equals 0. If I come over here to example, we'll call this 2, right? My horizontal asymptote, again, we're going to compare numerator degree to denominator degree. What is the degree of the numerator? 2. What is the degree of the denominator? 2. 2 is what to 2? Equal to. Okay, so I'm going to have a horizontal asymptote at y equals. You take the leading coefficient, the number in front of the biggest exponent in the numerator, over the leading coefficient of the denominator. So where is my asymptote at? 3 over negative 5. Perfect. And then let's go over here to example, quote unquote, 3. Compare the numerator degree to the denominator degree. What is the degree of the numerator? 3. What's the degree of the denominator? 2. 3 is what then 2? Greater than. So what's my horizontal asymptote? It's none. I'm going to give you a little hint here, guys. If you have a horizontal, you do not have a slant. If you don't have a horizontal, then what? You do have a slant. And the way that we would find the slant asymptote is long division. Right? You're going to do long division. So if you it says divide and set quotient equal to y. You have to have your equation written as y equals mx plus b. It's a line. It's not just y equals or x. It's y. It's got to be an equation of a line. So it would look something like this. If you had f of x, and we'll do this. I don't know. 3x squared plus 6x minus 5 over x plus 2. All right, if you compare the numerator degree to the denominator degree, it's 2 over 1. 2 is bigger than 1. That means your horizontal asymptote is non-existent. So for long division, we would say x plus 2 on the outside and 3x squared plus 6x minus 5 on the inside. Long division, guys. First term into first. X into 3x squared. 3x. Get your subtraction ready. Before you multiply, 3x times x is 3x squared. 3x times 2 is plus 6. Oh, this is terrible. Let's make this 16. It's a bad example. So 3x times 2 gives me 6x. What do I have to do before I subtract? Distribute, distribute, distribute. So what's 16 minus 6? Okay, so then I have 10x minus 5. And then I go first term into first term. X times what gives me 10x? Okay, so plus 10. So get your subtraction ready. 10 times x is 10x. 10 times 2 is 20. And then what do I do? Distribute, distribute, distribute. So I'm left with negative 25, right? Well, what does it say right here? You ignore the remainder. You do not include the remainder in your answer. So your slant asymptote is at y equals what? 3x plus 10. Always written as a line. But if you have a horizontal, you will not have a slant. If you don't have a horizontal, then you will have a slant. And again, once we go through the next 6 examples, you guys are going to be like, oh, this is easy. All right, last thing to talk about is something called the whole. It says a whole exists if you can simplify the function by crossing out common factors. All right? You want to always factor your rational first. Every single time you start this, you want to make sure you can factor. If you have a common factor on the top and bottom, you have to deal with the whole first. What the whole looks like in a graph is it would be like this, and then there's an open spot, and then it goes. So it would appear that there's a vertical asymptote there, but it's not. It's not a vertical line that doesn't cross. It's just one specific value that would make your equation not true, not exist. So this is what a hole would look like algebraically. Say you have all right, before we start answering any of the questions, the first thing I want you to do on all of these, and we'll do it, is factor. So what would you factor the bottom into here? X plus 3 what? X minus 3. Okay, so do you see here, guys, that you have a common factor on the top and the bottom? Yes. So right away, that should indicate to you, oh, we have a hole. Cross it out. You first determine where the hole is. So you have a hole at where X plus 3 equals 0. So what is the X part of my hole? X equals negative 3. Now, if you read the directions, it says to find the hole. Solution you crossed out, you said equal to 0. And then the simplified version, what do you think I do with negative 3? What do you think I do with x equals negative 3 if I'm trying to, because this is f of x, right? What's f of x the fancy way of saying? Y. So how would I find out what the y is if I know what x is? You not said equal to. You plug it in. If I know what x is, I'm trying to find y, plug it in. So it's 1 over negative 3 minus 3, which is what? Negative 1/6. So you have a hole that occurs at negative 3, comma, negative 1/6. So when the graph is graphed, you'll have your little boomerang line, and then there'll be a whoop, an open dot, because that one point cannot exist on the graph. We're not graphing these. We're just mechanically working through it. So now we're gonna find all the things. We're gonna find the holes first. You always want to look for holes first. Then vertical asymptote, slant asymptote, horizontal asymptote. You guys are gonna be great. All right, let's start with number 2. We always want to make a list. Go through our list. We want to find holes first. And then I like to do vertical asymptote, horizontal asymptote, and slant asymptote. Do you have to do it in that order? Absolutely not. I just am a creature of habit. How do we find holes? Well, let's factor. Is there anything I can factor in the numerator and the denominator? Make it smaller. No. So do I have holes? No. So you write none, guys. Don't leave it blank. If you leave it blank on the test, that means I don't know. You have to tell me there's no holes or none. All right, vertical asymptote. Go back to your little cheat sheet or whatever. How do you find the vertical asymptote? Set denominator, what? Equal to 0. So when I have this, I have 3x equals negative 2. So x equals what? Where's your vertical asymptote? At x equals negative 2/3. You absolutely have to have x equals and y equals. All right, the next thing on my list, I'm going to find my horizontal asymptote. Remind me again, how do you find horizontal? What do we compare? The numerator degree to the denominator degree. What is the degree of the numerator? 1. What's the degree of the denominator? 1 is what to 1? Equal to. So if it's equal to, you have a horizontal asymptote at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Y equals 2/3. Perfect. If you have a horizontal, guys, what do you know about your slant? It's none. The math behind this is super easy. You guys are not using P over Q and synthetic division, the quadratic formula. You're not. You just have to know where to look for the things. Zunigo, you good? Okay. All right, let's look at number 3. First thing we look for, we're going to determine the holes. We want to factor first, and then our vertical asymptote, horizontal asymptote, slant asymptote. Can you factor the numerator, guys? No. If it was x squared minus 1, could we factor? Yeah. Yes, but it's not. It's x squared plus. So what's my answer for holes? There's none. Good. All right, vertical asymptote. How do I find the VA? Denominator equal to 0. So what's my vertical asymptote? X equals negative 2. Guys, is there a lot of partial credit I can give you for this stuff? No. You have to know where to look for things. How do you find the How do you find the horizontal asymptote? What do we compare? The numerator degree to the denominator degree. What is the degree of the numerator? 2. What is the degree of the denominator? 1. 2 is what than 1? Greater than. So it's either none or y equals 0. Which one is it? None. If the numerator degree is higher than the denominator, you do not have a horizontal. So guys, if we don't have a horizontal asymptote, what do we know we do have? A slant. And how do you find the slant? Long division. So I have x plus 2 on the outside. And what do I have on the inside? X squared plus 0x. Perfect, Connor. Plus 1. Do I care about the remainder? Nope. So I'm going to say first term into first term. X into x squared goes how many times? X times. Okay. Get your subtraction ready before you multiply. X times x is x squared. X times 2 is 2x. Before I can subtract, what do I need to do? Distribute. So distribute, distribute, distribute. What's 0 minus 2x? Negative 2. And then I bring down my plus 1. And I say, again, first term into first term. X times what is negative 2x? Minus 2. Good. Do I have to worry about bringing down and all that stuff? Do I have to complete this problem, guys? No. How come? You don't care about the remainder. So how do I write my slant asymptote? Y equals. Perfect. Y equals x minus 2. On WebAssign, it's going to ask you for the vertical and horizontal asymptotes. It's going to say to write it as a comma-separated list. You have to write x equals whatever, negative 2, comma, y equals 0. If you don't write the x and the y, it's going to mark it wrong, which is good. It's a reminder of what you have to have. All right, let's keep going. You guys are doing great. Let's look at number 1 here. First thing I'm going to look for, again, get in the habit of doing the same thing. Whatever you guys want to do, just get some sort of habit that you have a routine and you go with it. So, first thing I look for is holes. Can I factor the top or the bottom? No. So do I have holes? No. All right. How do I find my vertical asymptote? My denominator equal to? Okay, so 3x squared plus 1 equals 0. 3x squared equals negative 1. X squared equals negative 1/3. And then what? Take the square root. When I take the square root of a negative number, what do I get? I get imaginary. So what do you think that means about my vertical asymptotes? There you go. All right, keep going, keep going. How do you find your horizontal asymptote? Compare numerator degree to the denominator. What is the degree of the numerator? 1. God bless you. What's the degree of the denominator? 2. 1 is what then 2? Less than? So it's what? Y equals 0. Good. If I have an horizontal, what do I know I don't have? There you go. You notice how I keep repeating myself, saying the same thing over and over, trying to get it in your brain. It's just very redundant. All right, let's look at number 3. What did I tell you guys we need to do? Let's make our list. I want to find holes first. My VA, my HA, and my SA. Make sure we know what those stand for. How do I find holes? So just guess? No, we got to factor. Does my numerator here factor? Yeah. To what? Plus 2 minus 1. Perfect. What about the denominator? Factors of negative 6. That multiply to give me negative 6. Add to give me negative 1. X minus 3 and x plus 2. What do we notice? X plus 2's. Cross that out and say, whoa, there's my hole. I have a hole at x plus 2 equals 0. So x equals what? Negative 2. All right, how do I find the y? Well, I take my simplified rational. I have x minus 1 over x minus 3. How do I find the y part of my whole? I'm going to plug in negative 2. So I have negative 2 minus 1 over negative 2 minus 3. What's negative 2 minus 1? Negative 3. What's negative 2 minus 3? Negative 5. So where does my whole occur, guys? At negative 2 comma 3 over 5. And now I take my simplified, because you guys would tell me here, oh, I have 2 vertical asymptotes. You really don't. You have a vertical asymptote and a whole. So you take your simplified now, and you can tell me all of the things. How do I find my vertical asymptote? What do? Denominator equal 2? So x minus 3 equals 0. What's my vertical asymptote? X equals what? Gotta have x equals. You guys are going to get mad at me when I take half credit off because you don't have x and y. It's a big deal. All right, my horizontal asymptote. I'm going to do it over here. What do I compare? Numerator to denominator. What is the degree? Guys, look at the original. What's the degree of the numerator and the denominator? 2 and 2, all right? Okay, say you go to the simplified one. What's the degree? 1 and 1. It's not the degree itself. It's the comparison between the two. 2 and 2 and 1 and 1 are what? Equal. So it doesn't matter which one you go to. I would always go to the simplified, but just in case. So if they are the same, I know my horizontal asymptote is at y equals what? 1. Degree of the numerator over degree of the denominator. Right? The leading coefficient is 1. Leading coefficient is 1. So it's just y equals 1. If I have a slant, guys, if I have a horizontal, what do I know I don't have? So my answer here is none. Do not leave it blank. I think I even wrote that in the directions on the test. If your answer is none, please state so. Like, don't leave it blank. How many think this is the hardest thing ever now? Yeah, it's not bad. All right, let's do number 4. Again, what should we try to do first? Okay, let's try to factor. Because the first thing we want to identify is a whole if there is any. Because we don't want to mistake that for a vertical asymptote. Then you have vertical asymptote, horizontal asymptote, and slant asymptote. All right, does my numerator factor? 3 times negative 6 is negative 18. Are there factors of negative 18 that multiply to give me negative 18, but add to give me 7? Plus 9 and minus 2, and then what do I have to divide both by? All right, so my numerator becomes x plus 3, and what, 3x minus 2? I told you factoring was never, ever going where? Never going away. Does my denominator, does my denominator factor? All right, what do I factor my denominator to? X plus 3 and x plus 1. Uh-oh, what do we notice? I have an x plus 3 in the numerator and where? And the denominator. So cross it off and identify your whole. You have a whole at x plus 3 equals 0. So what's the x part of my whole? Negative 3. How do I figure out what the y part is? Plug it into the simplified one. So I have 3x minus 2 over x plus 1. That's what I'm going to focus on now. So when I plug in negative 3 here, 3 times negative 3 minus 2 over negative 3 plus 1. What's 3 times negative 3? Negative 9 minus 2 is negative 11. What's negative 3 plus 1? Negative 2. So what's the y part of my whole? 11 over 2. So you have a whole at negative 3 comma 11 over 2. Little things like a negative divided by a negative equals a what? Positive, right? We have to, you guys have got to be diligent with that because negative 11 halves and positive 11 halves on the y-axis are in 2 different places. So go back to your simplified now. Let's talk about our vertical asymptote. How do I figure that out? Denominator equal to 0. X plus 1 equals 0. Where's my vertical asymptote? X equals negative 1. Perfect. My horizontal asymptote, I'm going to compare numerator degrees. What's the degree of the numerator? All right, you want to go back to the original? It's 2 and 2. If you go back to the simplified, it's what? 1 and 1. They both are what to each other? Equal. So if they're equal, it's y equals leading coefficient of the numerator over leading coefficient of the denominator, which is 3 over 1, or you could just say 3 if you want. If I have a horizontal, what do I know my answer is for slant? Good. Does anybody have any questions so far? We okay? It's the leading coefficient of the numerator over the leading coefficient of the denominator. So 3 over 1. Whenever the degrees are the same. All right, let's do these last guys. You guys doing great. All right, just little things I want you to pay attention. Yeah. Sure. Little things I want you to pay attention to. Matthias up here for 2 more minutes. What do you guys notice about number 5? Backwards, right? What do you think I'm going to tell you you should do? I would tell you to rewrite it. Some of you are going to just ignore me and do whatever you want, which, again, I get it. You guys know way more than I do. I understand. I've been teaching high school 23 years. But the reason I think it's a good idea to rewrite it is to alleviate silly mistakes. All right, first of all, write your list. Holes, vertical asymptote, horizontal asymptote, slant asymptote, right? Can you factor the top and bottom, make it any smaller? No, nothing is the same, right? So what do I write for holes? Perfect. Now my vertical, if you didn't rewrite it, you still would have gotten the answer plainly the same. What do I do for my vertical asymptote? Denominator equal to 0. So 2x equals negative 3. What's x equal? X equals negative 3 over 2. Here's why I say rewriting is a good idea. How do we find the horizontal? You compare the numerator degree to the denominator degree. If you don't rewrite it, where would we make a mistake? What's the degree of the numerator? What's the highest exponent, guys? It's 1. It's 1 and 1. So they're equal to each other, right? So what's your horizontal? Y equals leading coefficient of the numerator over leading coefficient of the denominator. What's a common mistake that would be made? You guys tell me it's what? 1, because you'd say it's 3 over 3, which is 1. Is 3 the leading coefficient? No, the leading coefficient is negative 7 in the numerator, and it's positive 2 in the denominator. If you don't rewrite it, you could make a silly mistake. I'm just trying to help you avoid that. So my leading coefficient is negative 7 in the numerator and 2 in the denominator. So my horizontal asymptote is at negative 7/2. And if I have a horizontal, what do I know I don't have? A slant. So we write none. Good. When we come back from Christmas, we'll do all this and then put it on a graph. Oh, I know. All right, first thing I write is holes. Then my vertical asymptote, my horizontal asymptote, my slant asymptote. Factor first, guys. Can we factor this? Yes. I have x plus 3 in the top. And then what do I have on the bottom? X plus 3 and x minus 3. Immediately, what do I see? X plus 3 on top and bottom. Cross it off. You have a hole at x plus 3 equals 0. So what is the x part of my hole? What's the x value? Negative 3. Good. What is left over? What is my simplified function that I'm going to look at now? 1 over x minus 3. Make sure you remember, guys, if there's nothing in a numerator, there's a 1. So how do I figure out the y part of my hole if I have a simplified version of my function and I know an x value? Plug it in. So I have 1 over negative 3 minus 3 gives me negative 1/6. So where does your hole occur? Negative 3 comma negative 1/6. Perfect. Now everything else is based upon your simplified. How do you find your vertical asymptote? You set the denominator equal to 0. So where is my vertical asymptote? At x equals 3. Got to have x equals. Compare, guys. We're going to compare for our horizontal asymptote, numerator to denominator. If you go back to the original or if you go to the simplified one, you're going to get the same answer. In my simplified version, what is the highest exponent you see? What's the degree of the exponent in the numerator of your simplified version? 0. What is it of the denominator? 1. All right, if you go back to the original, it's 1 and 2. But again, 0 is what than 1? Less than. 1 is what than 2? Less than. So what's my answer for horizontal? Y equals 0. If I have a horizontal, what do I know about my slant? None. Very good. All right, 2 more, then we're done. Write your list. Holes, vertical asymptote, horizontal asymptote, slant asymptote. What do I need to do first? Factor. Very good. What does the top factor into? X plus 2, x minus 2. What about the bottom? X minus 1, x minus 2. Okay, what do you guys see? I have x minus 2 twice. I immediately say I have a hole at x minus 2 equals 0. So what is the x part of my hole? 2. How do I figure out what the y part is? Plug into the simplified version. So I have 2 plus 2 over 2 minus 1. What's 2 plus 2? 4 over 1. So where is my hole? 2 comma 4. Good. 2 comma 4. Now everything else is based upon our simplified version. Most of you can look at that and tell me where my vertical asymptote is. X equals 1. Where did we get x equals 1 from? Set the denominator equal to what? 0. Okay. How do we find our horizontal asymptote? We're going to compare the numerator to the denominator. Go to the original, go to the simplified. You get the same answer. In my simplified version, what's the degree of the numerator? 1. What's the degree of the denominator? 1. 1 is what to what? Equal. So I say my horizontal asymptote is at y equals, what is the leading coefficient of the numerator and the denominator? 1. Perfect. And if I have a horizontal, what is my answer for slant? None. If my answer for horizontal is none, what do I know my slant? Will I have one? If I have no horizontal, then yes, I have a slant. All right, let's do this last one, and then I want to bring up one other example. You guys do this one, and then I'll do it, and then show you my answer. All right, did you guys get the same answers I did? When we factor, we had a common factor of x plus 2 in the top and the bottom. Agreed? Okay. So then I identified my hole. The x part was at x plus 2 equals 0. So you solve it, get x equals negative 2. We plug negative 2 back into our simplified version, and we get y equals 1. So you have a hole that occurs at negative 2, comma 1. Everybody agree? All right, then I go back to my simplified. How do you find the vertical asymptote? You set the denominator equal to 0. So 2x plus 1 equals 0. Solve it, you get vertical asymptote at x equals negative what? 1/2. Then for our vertical, horizontal, we compare our numerator to denominator. Go to original, go to the simplified. 1 equals 1, 2 equals 2. So your horizontal asymptote is going to be the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator, which is 2. And if we have a horizontal, what do you know about your slant? You don't have one. All right, one last thing I want to talk about, and then we are finito. Say you had this, guys. You don't even have to write this down. You can just watch. You have f of x equals, we'll say, x plus 7 over x squared plus 7x plus 12. All right, first thing you want to check for is holes, right? And then your vertical asymptote, your horizontal asymptote, and your slant asymptote. So how do we check for holes? What do we have to do? We have to factor, right? So top is x plus 7. Does my bottom factor? Yeah, x plus 3 and, okay, x plus 4. Do you have anything that cancels, guys? No. So what's your answer for holes? You don't have any. That's fine. What would your vertical asymptote or totes be? You would set everything in the denominator equal to 0. This one happens to have how many vertical asymptotes? 2. That's okay. So you have a vertical asymptote at x equals -3, and you have a vertical asymptote at x equals -4. If you don't have holes in the graph, guys, and something factors, then you just have more than one vertical asymptote. No big deal. But that's why you have to factor first, because you have to make sure that you don't say that something is a vertical asymptote when it's actually not a whole boundary line. It's just one teeny little point on the graph. All right, let's find our horizontal. We compare numerator to denominator. What is the degree of the numerator? 1. What's the degree of the denominator? 2. 1 is what then 2? Less than. So what is our asymptote? 0 or none? Look at your thing. Is it y equals 0 or is it none? And then we have a slant asymptote. It's y equals 0. You guys have to remember that. It's easy when the leading coefficient, when the degrees are the same, and then it's just leading coefficient over leading coefficient. But if I have a horizontal, then I know I do not have what? A slant. So my here would be none. If you guys get that confused, think about it. Try to divide x squared plus 7x plus 12, because long division is how we find our slant asymptotes, right? So x squared into x goes how many times? It doesn't. So then you should go, oh, wait a second. Then it's not then it's not none for my horizontal because my slant is none. So then you go, oh, okay, it should be 0. There's always little ways to check, to think. So tomorrow in class, it's a web assign day. It's a work on the review day. It's asking questions about calculator day. But it is a day that you guys will be working, 100%. You guys did great today.